Okay friends, so now we see that both Newman and Concor groups have been added as the features in the node set table, and now we are going to run some reports. So generate reports. There is a rich set of reports. So in the categories you need to go to, first of all, locate characterize groups and networks. This is the main option, and within this we have locate groups. So you select locate groups, no other input filtering. Next we select the node set and the network. Next, so here it shows the possible algorithms available for the subgroup analysis or the community direction. So two of interest for us are the Concor grouping and the Newman grouping. So note this Jirvan Newman grouping and Newman grouping, for us they are same, so we'll use the Newman one, this one, not this one. But at the advanced level there is a little bit difference how the system actually works out the grouping. So we first conduct the Newman grouping, and probably we also have some general options. We have to for example, the minimum group size to be analyzed is 1, right? So that the system does not stop at 5, even if a group has just one, as we just saw, F1 was just one node in a group, so the system should report it. And group cross group network. So this is the model that we discussed in the earlier video, block model. So we want this, and the block model has to be reported by density, right? So it is by default selected as density, so yes, we go with it. And then if you come downwards, there is one more option to add, is that add located groups network to the input meta network. So we shall have another network, which is the group cross group network, which we want to add. And we do not want to add attribute because the attribute has already been added. So if it has not been added, we can add it, but since it has already been added, so I don't want to add attribute again. So next, I want the report to be in HTML. Yes, an earlier report has been overwritten. Okay, I'm okay with this. So here's the report. So we have the meta network banks, interbank loans is the name of the network. Minimum group size we have set is 1, right? So it means that this is the benchmark that we set, right? This is not the actual data is somewhere in the main body of the report. So this is the clustering coefficient of the network. So recall, the clustering coefficient is the measure of local cohesiveness. So to what extent any 3 nodes selected are actually making triangle, any 3 connected nodes or 2 connected nodes and then taking third are making a triangle. So 15.8% of the times we have triangles. It means not a very comprehensive cohesiveness, local cohesiveness. And the modularity, now this is the measure of the strength of the grouping. So strength of the grouping is 0.35. It is more than 0.3, it means yes, there is a moderate clustering. So recall that modularity is by definition is always high when we do the Newman grouping, because the way the Newman grouping actually groups the network, detects the communities, is actually the same as the measure of the modularity, which is to what extent the links within a group are cohesive, are more dense than the links outside the group. So let's see the group memberships. So group 1 has 4 members, group 2 has 4 members, group 3 has 3 members, right? So this is what we also saw probably in the visualization. And then number of groups are 3, and then there are no isolates, no diates. Number of triad groups, there is 1 triad group, but this is again not a component, right? So now this is actually reporting the groups, and recall over here what we see, isolates, dianes, diets is the components, right? So this should be kept in mind. Largest group size is 4. So again, this is something simple to comprehend. And now this is the main table of interest, right? So group 1 size 4, density 0.5, weighted density 0.5 because there are no weights. Group 2 density 0.5, group 3 density 1, and the link values are minimum maximum 1 because it's a binary network. Internal links 2, external links, internal links 3, external links 2. So we can work out the pseudo index, which is the internal links minus external links upon total links, right? So the pseudo index is actually just the minus of external internal index. So this is the formula of this is this minus this 2 minus 3, which is minus 1 oblique total count of links 5. So minus 0.2, whereas the silo index is 3 minus 2, which is 1 oblique 5.2. So yes, this the silo index of this group is 0.2, whereas the silo index of the other groups is 0. It means they are not disconnected with the rest of the community. They are equally connected within the network as well as outside the network. The count of links actually shows this. Shear value is something that outside the scope for us to discuss. And now let's move further down. Now one more thing to note is that the density of each of the group has to be more than the density of the network. So see, the total density of the network is 0.319, but density of each of the group is 0.5. And this is always valid in the Newman grouping. It's not valid in attribute-based grouping, and it's just absolutely not valid for the Concor grouping, right? But in the Newman grouping, always the density of a group will be more than the density of the network, because this is how the Newman algorithm works. It groups those nodes together which are more connected. It means the density of that particular group will be more than the overall density of the network. So leave this table and now this is the group nodes with highest internal degree. So for each group, the sequence, the order of degrees, internal degrees. For each group, the order of external degrees, probably HIA index, right? So again, this is not very much important for us. Group hubs, group bridges. So within the group, which node is the bridge, which node is the hub, right? So this is also the table showing for each group. So we have already calculated the hubs, and hub is actually the degree centrality and betweenness centrality. This is the group bridge is the betweenness centrality. So for every group, for each of the groups, right? So they have colored it by groups. So again, not very important for us. For the next important thing is the block model. So you see the block model as just we saw in the theory, that this is how the block model works, and also a block model for densities. Now this is something very important. Group 1 versus group 1, the density is 0.5, we just saw. Group 2 internal density is 0.5. Group 3 internal density was 1. So we saw earlier in the table as well. And these are the across the group densities, which are always less than the network density as well, and of course the group density as well. So this is the block model visualization. So this is how we make sense of the subgroup analysis report. And if you focus just on this densities, it means group 1, say if this is a collaboration network, right? So group 1 collaborates just 0.0625 with group 2 and 0.083 with group 3, but within the group the collaboration is 50%, and we can read all the other values accordingly. So now just go back over here. Now you see 2 more networks have been added. This is the banks into Newman grouping. If we visualize this network, see what it shows. So it shows just the one node as a new groups, and then each of the node is connected to that group particularly, right? So this, but we are more interested in this one, density block diagram, right? Okay, so we have to show this one as well. Okay, so let's do away with this one. No, we know we want this, do away with this one. Okay, so how group 1, group 2 and group 3 are connected, right? So for example, okay, so we don't want this as well. So how group 1, group 2 and group 3 are connected? So they are connected in one way or another, because there is some value more than 0, and the values are actually the densities which we can see over here as well. If we come to this block model editor, you see these are the densities showing over here, which we just saw over there as well. So that's is the way we do the analysis, the simplest possible analysis that we do, being the beginners. And now in the lab part, I'll share another data set, network data, for which you have to perform the analysis and submit some required reports. So refer to the LMS. Thank you.